Hey everyone, welcome to week 3 of Building Server Systems. It's your friendly neighborhood instructor here. I just wanted to provide kind of an overview of Chapter 6, which is one of the primary focuses this week. And this is just not meant to be a comprehensive summary of all of the content. You definitely need to read the book, and this PowerPoint, as I'm sure you'll notice, is based on the content of the book, and specifically in this case Chapter 6. But note that you do have a little bit of Chapter 1 to finish up this week as well, and I'll address the other content in due time. So Chapter 6 is floors and exterior walls, so we're really going to start looking at how a building is put together. This is really important to understand. If we're looking, if we want to know all of the systems in a building, we need to know how a building is constructed. I know that many of you do have experience with construction, and you're probably really familiar with how a building is put together and all the different components and the framing and so forth. And that's fine, so you may be able to buzz through this video pretty quickly, and the reading will hopefully just reinforce things that you already know. But if you don't, if you don't have experience with it, it's really important that you understand the basics of how a house is put together. Because in order to understand how the systems can operate most efficiently, you need to understand how the house is put together as a system. So that's kind of the focus of this chapter. So there's a number of different ways to build a building, both historically and contemporarily. There's not just one way to build a building, and we'll go over a couple of them this week. Balloon framing is one of the oldest ways to build a building, and I'll show an example of that. But that's when you use really long, continuous studs that can be multiple stories high. Whereas platform framing is how most of our modern homes are built. There are some other, I guess you could call them niche construction methods like panelized framing and modular construction. We'll go over those as well. So there's a lot of different ways to put a building together. Balloon framing was one of the original ways to put together a house. So there's a lot of balloon frame homes actually in this area. If you see a house that was built before like early 1900s and before, you'll probably see balloon framing. And balloon framing is very distinguishable because if you can see here, these studs go all the way from the first to the second floor. So it's one continuous. So it's back when they had old growth trees, and they were cutting boards that were 20 feet long, even longer sometimes. But there are some drawbacks to this. You have these cavities that go all the way from the basement to the attic, so it's really not good for energy efficiency. It's not good for fire suppression. And also it's just hard to find wood that's that straight and that long anymore. That's balloon framing, and I'm not going to go into detail about all the different components. But platform framing is the modern framing method, and this is how houses are pretty much built today. And you can see platform comes from the name. There's sort of two. It's built platform by platform, right? So these studs are usually 8 feet tall. You have 8-foot ceilings. And then you just sort of build one floor, and then you build another floor that's basically identical in terms of all the components, with the bottom plate, the top plate, and the joists, and the headers and all that. So that's our modern type of framing that you'll see most of the time if you go out into a residential or a commercial building. There's also modular construction. This is relatively new. And in this type of construction, a lot of the components are actually put together off-site. So you'll put together like the roof boxes. You'll have basically you build the house in pieces, if you will, and then you bring those really big prefabricated pieces on site and you put them together. So there are some advantages to this in that it's a little easier to control the conditions, right? So a lot of these are built inside, like in warehouses and so forth. So there are some advantages to it, but there's also some advantages to this, and your book will go into that as well. A lot of the book focuses on sort of the process that you use to think about building a house or renovating a house and so forth. And so they do go into some details about some aspects of the building site and other aspects of the job that can impact your decision on what to do. So actually the COVID era, which we're kind of getting out of now, is a really good example of this. It's been really, really difficult to get certain materials, and everything's kind of been taking a long time. So you really have to plan extra carefully if the given all of the conditions. Skilled labor has also been a problem recently as well. So you have to look at how easy it is to get to the site. And of course, we like to focus a lot in this class on green buildings and energy efficient buildings, and we'll get into that in more detail later, but very important to consider local climate conditions. We don't want to build these one-size-fits-all houses and just like plop it there irrespective of where the sun comes in or where the prevailing breeze comes in and so forth. So you really want to consider the local conditions as well. All right, and again, you just need to make sure if you're going to build something, you have the skilled labor available to you, and also that you have the resources to hire that labor as well if you don't have them on staff. And again, site accessibility, you really need to look at the whole site as a system, and that's a really, really important concept in green building. You don't just look at like, okay, I have this pad where I'm building this house and this is the house footprint. You have to look all around. Where does the water drain? Where does the sun come in? How does it connect to the local community or the public transportation routes? There's all kinds of considerations once you get into more advanced green design. And again, climate is really important in terms of the materials you use, but also the way you design the house. Wood is the main component of buildings. You probably know that. There's advantages and disadvantages. There are some advantages to using metal framing and artificial or non-organic components like for insulation and some other aspects, even for some structural members. But wood is your primary component, and in the book they get into a little bit about the different sources of wood. So again, green building, we're trying to be as environmentally conscious as possible. So you don't want to take wood from old growth forests, which are like original. Well, there's really not many true original forests left, but really old forests. If anything, they need to be harvested sustainably. And one benefit of wood, since climate change is a primary consideration in green building and the modern building industry and the modern world in particular, one benefit of using wood is that if you regrow them, they actually do, they sequester carbon because they pull in carbon dioxide from the air. And then as long as the house stays up, that carbon stays in the wood. So in a way, they are carbon sinks. Now the problem is if you tear a building down, tear a house down, and then if you let that wood decay or if you burn it, then that carbon goes right back into the air. So you do have to consider that as well. And there are different certifications that your book will get into. The Sustainable Forest Management, which is not super common. The Forest Stewardship Council is a really common one, and as well as the Sustainable Forestry Initiative. So these are all third-party certifiers that they basically go out and see how the wood is being grown and harvested, and even to the extent of is it being respectful of local indigenous populations and so forth. So you'll read a little bit about these, but it is important to consider the whole life cycle of your building, and a lot of your building starts as a tree somewhere, so you want to know that your wood is being harvested in a relatively sustainable manner. These all have sort of pros and cons, but it is important to consider. And again, wood is relatively climate friendly, as long as the wood's still in the house, the carbon stays locked up. But then at the end of life is kind of where you can get some issues with carbon emissions. And there are some different building components that aren't natural, like just regular wood studs. So we have engineered lumber, which is sort of like there's different types, but basically you can really specifically design these so they're basically perfect dimensions and so forth, as opposed to taking a larger tree and sort of milling it down. And you look at all the different building components, trusses, joists, the book gets into some of the benefits of engineered products, and there's also some drawbacks to engineered products. Among them, there are some chemicals in there that you don't always want to be outgassing in your building. But you also have some engineered wood products that are used really commonly. Plywood is a really big one. OSB, or oriented strand board, really common to use as sheathing on the outside, sometimes called press board. Laminated beams, finger jointed studs. I mean, there's all kinds of different engineered wood products. So these are engineered wood products. They're wood that are sort of made various ways, chopped up and glued together and pressurized and so forth. And these are, especially plywood and OSB, those are really, really common to see on building sites. Solid milled lumber is not used all that often anymore. That was kind of the way they used to do things. Now we're much more into the engineered wood components, but it can be part of a sustainable home, as they mentioned in the book. A really important consideration is moisture and pests. Moisture in particular, there's nothing more damaging to a home than moisture. Pests, of course, are as well, like termites and so forth. That's a little bit less common, but moisture is a really common problem in buildings, so moisture management is absolutely an essential consideration. So you need to have moisture barriers in the proper locations. Only certain types of wood can be used where it can be in contact with groundwater. It's just absolutely essential to keep moisture out of a house and control moisture in a house. There are treatments for mold and moisture as well. Don't really get into a whole lot of detail of those. They do make some chemical treatments for wood that prevent pest issues. Like blue wood is one example of that. It uses like a borax, I believe, so it's like a natural pest repellent. So there are some are better than others, and then of course you have your weather treated wood that can be in contact with wet ground and be okay. So there are they do go into some of the more advanced framing techniques in the book. And this is becoming a little more common, although we're still just generally building the same way that we have been for the last 50 years. 16 on center studs and double top plates and so forth. So this is kind of a burgeoning movement, especially in the green building movement, to do these advanced or smart framing techniques, and they will get into that a little bit. One of the main things you want to do with these advanced techniques is just reduce the amount of wood that you use, because the more wood you have, the less insulation you can put on there. It's a little bit of an oversimplification, but you want less framing so you can have better insulation. And that's becoming a little bit more common, but there's some structural issues to consider as well. But again, most of them conventional wood framing, that's what you normally see, the regular stick-built houses, platform framing. Advanced framing, optimum value engineering, big fancy word. They call it any number of things: smart framing, advanced framing, OVE. And you basically want to minimize your material use, minimize your wood use, so you can add more insulation and have a tighter building and have less what are called thermal breaks. So there are some benefits to this. It can reduce the amount of material, it can reduce the amount of wood, and if done properly, it doesn't compromise the structural integrity of the house. But it does take a lot of planning. It's more difficult. It's a more specialized skill. It's not quite as easy to put together, I guess you could say. You have to be a little more careful. It's a little less forgiving in terms of the building itself. You have to be really careful about the loads and where you're using, load-bearing walls and so forth. But it does save ultimately. It is a little more expensive to build these normally because they also have usually thicker walls and more insulation. But ultimately, the building does, if you live in it long enough, will pay for itself by saving the reducing your energy costs. So this is just some examples of some of the advanced framing techniques we'll kind of get into a little bit. You basically just want to reduce the amount of wood as much as possible. Again, that's the big thing here is extra insulation. Thermal bridging is really one of the main enemies of energy efficiency in your building. Wood is a terrible insulator. It's terrible. It's R1 per inch. The heat will travel pretty quickly through it relative to insulation. And so if you don't want a thermal bridge is basically when you have a continuous bridge of a highly conductive material going from inside the house to the outside. So if you have a wood frame that's inside wall, outside wall, that's a thermal bridge. And metal framing it's like 10 times more conductive, so it's a really strong thermal bridge. And so you want to have a thermal break. If at all possible, you want to have insulation completely continuous around the building. And that's why sometimes in the more advanced and more energy efficient buildings, they'll wrap the whole exterior of the building in insulation to prevent thermal bridging. Wall sheathing is just the wood on the outside. Usually this is going to be OSB, but there are some other materials. There's your OSB. Plywood is much less common. OSB is cheaper, and it's structurally it adds structural integrity. There's some other wall sheathing, right? So wall sheathing is the stuff on the outside. So they do make some different ones that are a little more insulative and energy efficient as well. All right, so insulated sheathing. Again, if you want to wrap your whole house in insulation, you want to do that, and that's what insulation sheathing will do. There you go. Here's a picture of some insulated sheathing. Here's your insulated sheathing, and then you've got some structural sheathing here in the corners to keep I don't know if this picture it might have insulated sheathing all the way around and then structural on top. So sometimes they'll do like an inch of insulated sheathing and then do like a ½ inch of insulated and a ½ inch of structural, so it's flush. But this is an advanced building technique. So floor decking is basically your subfloor. That's what you're walking on. And most of the time it's going to be plywood or OSB. Again, OSB is the cheapest version of this. Solid lumber that's sometimes used, like so at my house I do have some hardwood floors and some on my second floor, and so that's actually boards, but that's a little more labor intensive to put in, and plywood and OSB is much more common. Adhesives are an important consideration there because it reduces creaking and just makes it a little more solid. Right, so fasteners and adhesives. Yep. Nails can be used. I think you all know what nails are. So another advanced building technique is our manufactured components, and there's a couple different kinds, like structural insulated panels and insulated concrete forms and so forth. So these are things that are pre-made, prefabricated in pieces somewhere else, and then they're brought on site. So they can be a little more energy. They're generally more energy efficient. They generally do reduce waste because they're made on site under very optimal conditions. So structural insulated panels are not really common, but they're, in terms of your manufactured components, they're fairly common, and they're basically like wood that think of like a foam sandwich. So you have wood on the outside, and then you have it sandwiching this piece of foam. So it's total thermal. It's insulated all the way around, so there's no thermal bridging because it's insulated the whole way around. Now these have to be prefabricated. and it can get a little bit tricky because you have to like really figure out your building design beforehand and cut them and build them on site. But they're very high R value. You can put it together really quickly, and again, like your pieces are there, and you're just kind of like putting the pieces together. So there's much less building waste. So SIPs, just like anything else, you have to be really careful. And they are structurally sound, but they're not the traditional framing, so you have to be a little more careful and have sort of special training to design a SIP house. Yeah, they can be quicker to put together. Yep, it's pretty quick, reduces the waste. I don't know, that seems like kind of a repeat there. So modular construction is where you sort of put the house together in pieces off-site. So here's a good picture of that, and it's like you can customize this, and that you can sort of you basically put your house together in pieces, and you can sort of put 4 of them together to make like 1,000 square foot ranch, or you can stack them on top of each other and make a 2,000 square, whatever. But this again is sort of really an efficient way to build, because you build them off-site under optimal conditions. You can really tighten them up. You're not worried about weather and so forth. And once they're on site, it's relatively quick to put together because most of the pieces are there. And so these are usually a little bit tighter, a little bit more moisture resistant. As I said, the quality control is generally really great because they're building in these like factory conditions, which are ideal. And a lot of these modular homes in particular, they're doing like net zero modular. I think there's one in Delaware called ZMod that does net zero modular homes. So it's becoming kind of this burgeoning movement. Timber framing is like an older way to do things, but there's some modern timber frames. I'm not sure, but there's like big poles that are basically supporting the weight. Log homes, now this is a little bit of a niche application, but most log homes now, so the old log home is actually built with a log. The walls are made of logs. The modern log homes, most of them, the logs are more of a like almost like a veneer, right? So they're outside and there's still structural members inside. Although they do still make some log homes. The problem if your walls are just made of logs, you really don't have much insulation, so you're gonna have to add insulation inside. And it can be a little bit, they do breathe as well, so you need to be careful about moisture, right? So that's just, I think everyone knows what a log home looks like. Unit masonry is basically like, think of concrete. Concrete's a really good example of unit masonry. So there are some advanced versions of this, like an ICF, which is an integrated concrete form. They use these for foundations. It's kind of like the structural insulated panel, but it's the outside is foam and the inside is rebar. They have rebar and they fill that with concrete. And so then you have basically the structure and the thermal mass of a concrete, but also with some insulation. But you can also build walls with them as well. And this is just an example, a concrete slab floor, which is not uncommon in this area. Actually, there's a good amount of ranch homes that have concrete slab floors, and they're pretty good. They're a good thermal mass, so they're good absorbing sunlight, and you can build just about any type of house on top of a concrete floor. Then there's some of these really niche applications, these sort of alternative construction methods, straw bale, cob, rammed earth, adobe. These are all really interesting, and hopefully we'll get to see some of them this semester, but they're very uncommon. They're generally considered the most authentically sustainable buildings because they're made of natural materials. They're usually built by hand, not necessarily with a lot of times with a fully integrated planning process. And you can kind of do a lot of them. Straw bales, believe it or not, are actually made of straw. So the straw basically forms the inside of the walls, and then you have the framing on the outside, and the straw acts as a really good insulator. as long as they are susceptible to moisture, but only if you don't properly seal them. Cob is really cool. Cob is a mixture of clay and straw and some sand, and you basically you build it layer by layer, and you can build the house any shape. So think of like clay, you can build any shape. So just like that, a cob house, you can build any shape. Like that's a good example of cob. You just put it together, sort of layer, and let it dry. Another layer, let it dry. Really cool building method. I've seen a few cob houses in my day, and they're really neat. Totally natural, because you can just use. I mean, around here, there's ample clay, so you could build cob houses all day. Rammed earth is, again, it's another one of those natural building techniques. And there's also, in terms of green building, you can do green remodeling. And so that's also a really big part of the green building movement. I mean, we have all these existing buildings, so it's a lot of times much more, has a much lower life cycle impact. Instead of tearing down a house and then building this fancy new net zero house, which is great, I guess, if you're recycling all the materials, but you have all that loss, you're recycling materials, you're using all the energy to tear it down, you got to ship things in. So if you can retrofit and remodel an existing home to be energy efficient and maybe even net zero, then that's actually a really good way to go. Okay, so that's an overview of Chapter 6. I hope you enjoy the content, and I look forward to having discussions about it.